question here is asking us to resolve each force acting on the past into its x and y components. Also determine the magnitude and angle of the resultant force. In order to determine the magnitude of the resultant force, we have to resolve first each force acting on the past into rectangular components. Then from the resultant force magnitude we can determine the angle. So the first thing, you take all the information being given to you and write it down or interpret it down mathematically. So the first step you should do is write down what is being given. The three concurrent forces. So you have F1, which is 300 Newton. You've got also F2, 450 Newton. And you have F3, 600 Newton. For F2, you have theta equal to 45 degrees. And for the F3, you've been given special triangle 3, 4, 5. So once you've written down all the information being given to you, start planning your questions with, see what is unknown or what is needed. Unknown or what is needed. What is needed, we need to find out the resultant force, the magnitude of that resultant force. Also, we have to find out the directions of the resultant force. In your solution, the first step is the free body diagram. In your free body diagram, interpret or resolve each force into two rectangular components. So F1, which is 300 Newton, doesn't have X component, it's got only Y component. F2, your F2, it's 450 Newton. Resolving this into two rectangular components. And you have F3, 600 Newton, and it has special triangle 3, 4, 5. I like to number all of my angles: theta 1, theta 2, theta 3, theta 4. Once I'm done with the free body diagram, I start down solving the question. So I start with F1. For F1 on the x directions, it's 0 Newton, it doesn't have any components on the x-axis. For F2 on the x-axis, I need to find out how to get these components in there, and it's a negative x-axis. So basically from here we can say cos theta 4 equal negative F2 on the x-axis divided by hypotenuse, which is the F2. I can now solve for F2 on the x-axis equal to F2 times cos theta 4. Plug in the values: 450 Newton, cos 45 degrees. This one here should result in negative, because this one here it's a negative. Take that negative to the other side, of course. That should be negative 318.2 Newton. What about F2 on the y direction? For this one here we can say sine theta 4 equal F2 on the y direction divided by F2. So solving for F2 on the y direction is equal to F2 sine theta 4 equal to 450 Newton multiplied by sine 45 degrees. this one here should equal to 318.2 Newton. For F3, it's directly here we don't have the theta, but we have that special triangle. So F3 on the x direction equal, so 3 corresponding to the 3 here corresponding to the x axis, so 3/5 multiplied by F3, which is 600 Newton. So in this case equal to F3, when you multiply these two together, that should equal to 360 Newton. F3 on the y-axis, do the same thing, 4/5 multiplied by 600 Newton, and that should equal to 480 Newton. Now once we resolved all of these forces into x and y components, now we just sum of the forces. Sum of the forces on the x-axis should equal to F1 on the x-axis plus F2 on the x-axis plus F3 on the x-axis. That all should equal to F1 on the x-axis is 0 Newton, F2 it's a negative 318.2 Newton, F3 in this case it was 360 Newton. When you sum all of these, they all should equal to 41.8, if I'm not wrong, Newton. So sum of the forces now on the y direction, we do the same thing, F1 on the y plus F2 on the y direction plus F3 on the y directions. All of them equals to, this one here it's 300 Newton plus 318.2 Newton plus F3, in this case it was 480 Newton, and all of them should equal to 1098 Newton. Once you got your sum of forces in the x direction and sum of the forces in the y direction, it's easily now to find the resultant force. In this case, the resultant force will equal to the square root of the sum of the forces in the x direction, which is 41.8 square, plus 1098 also for the y directions squared. This resultant force here should equal 1098.7 Newton. To get the directions of it, of course we will use the inverse tan of the absolute values of F on the sum of the forces in the y direction divided by sum of the forces on the x direction, and that will equal to 87.8 degrees. Since it's positive x and y, and we're having here x and that's y, and it is 87, there's your resultant force in here, 87.7 degrees.